Hey, Math 2, Miss Reynolds here. We're going to finish quizzes, Projectile Motion 2, going over these next 4 examples. Number 4 through 7, we will need to use Desmos to figure out what key features is asking us for. So the first thing we need to do is type these equations in. I'm going to use X and Y just because that's what we're used to seeing, and I prefer to use X and Y. Y equals negative 16x squared plus 80 b plus 25 instead of x. And let's just show for a second that it doesn't really matter what variables we use. If I used b and h, it's still going to give me a parabola. So let's adjust our window here so I can view my parabola. So, and there's an easy way for me to see what window is going to make this easier for me to look at. So if I click up here, I see my maximum height is 125. So I can see right away that my answer for number 4 is going to be 1. That's supposed to be a highlighter. 125. 125. So now let's talk about how we can adjust our window. So if I see my maximum height is 125 and my maximum X value is 5, if we click over here on our little graph settings button, I can change my X axis from 0 to 10. And already right there, that already helps a lot. So just by changing your X axis, it will make your parabola a lot easier to view. So let's talk about this information for a second, because right here, understanding what these 3 points mean in context to this word problem is going to solidify whether or not you can interpret projectile motion problems. So looking at the equation, h equals negative 16t squared plus 80t plus 25, just looking at the equation, I know that my initial velocity is 80. So I know that my initial velocity is 80 and my initial height is 25. I can also back up my initial height being 25 from this right here, my y-intercept. This is the starting point. It's launched from a height of 25 feet. And here, this x value, 5.295, that is how many seconds the object is in the air. It hits the ground at 2.95 seconds. It reaches its maximum height at 2.5 seconds. So after 2.5 seconds of this object being launched, it reaches its maximum height. All right, let's look at number 5. A rock is dropped from a drawbridge 320 feet above a river. The pathway that the rock takes can be modeled by the equation h equals negative 16t squared plus 320. How long will it take the rock to reach the river or the ground? So what happened to our t term? Let's write this a little smaller. Where is t? Where is t? So if we're looking at our velocity, so in this other problem I had t value, 80t. This one I do not. And that's simply because my object is being dropped. When my object is being dropped, I have an initial velocity of 0 feet per second. If I'm holding something in my hand, at that exact moment when I drop it, it has no velocity. We did an example like this in class where I dropped something on the floor and I asked you guys, how fast is it going at start when I first drop it, how fast is it going? At 0 seconds, it's going 0 feet per second. It's not going anywhere because I haven't dropped it yet. So that's why there is no t term. And then 320 shows our initial height. That negative 16 out front is the acceleration due to gravity. That's all you really need to know right now about that term, and it's something that you'll learn more about in physics or calculus when you take calculus. So how long will it take the rock to reach the river? So first we need to go back in to Desmos and enter this new equation. So our new equation, we have h equals negative 16b squared. I'm just going to stick with h and t because I'm going to keep typing it in when I see it. Plus 320. When is it going to hit the ground? So I don't even really need to change the view of this window. All I need to see is that intercept right there, 4.472. And the closest answer we have to that, we see this is a rounded answer. I have 4.5 seconds. All right, now I want you guys to open Desmos. We can use the link in the description to figure out what the answer is to number 6. Joe hits a fly ball. You can track the height of the ball using the equation. What is the starting height of the ball? This is not even one you need to put in Desmos. So take a second and see if we can figure this out. What is the starting height? Remember what we know about the equation. Y equals mx plus b. What do we know about that equation? So if I've got y equals, not mx plus b, Lord have mercy. That's the equation for a line. Y equals ax squared plus bx plus c. That's the equation I meant to say for a quadratic. What do we know about this c value? That's going to be our starting height. That's going to be the y-intercept of our parabola. We can type that into Desmos to confirm. Last but not least, okay, so here we're using our information from the problem to write our equation. So this is where it becomes important to understand the vocabulary for projectile motion. So a ball was thrown from a height of 5 feet, so that's going to be my c value, with an initial velocity of 24, so that's b. And we know that we're always going to have negative 16 out front. So I can rule out c and d because they don't have negative 16 out front. And I can't have a negative initial height. I'm not going to throw this from underground. It needs to be above ground. So process of elimination, our answer for number 7 is A. So we need to make sure we understand these terms. We need to make sure we are studying our Quizlet, and you need to let me know if you need more practice or more examples. Ms. Reynolds, signing off.